Hi, everyone. Welcome back to our webinar series. I hope everyone is doing well. We are approaching the end of this year. Only literally 31 day left. Hopefully everyone is excited for that. I don't know if you've made your New Year's resolutions yet, but maybe it's time to start thinking about those. We're super excited for today's webinar because it's a special edition. And we have a star presenter here with us today, Aravind, who has authored the white paper that is going to be reviewed today. Gonna turn over to Aravind just to say a few welcoming words, and then we'll jump into some of the admin things.
All right. Thanks, Olia. Hi, everyone. It's great to be here. There's a lot to discuss today, so hopefully you've got a lot of questions. I think Olia is going to talk about how the webinar is going to go for those that need a quick introduction. So yeah, Aravind, I'm the founder of TerraWatch, which is a strategic advisory firm focused on Earth observation. I've been in Earth observation for the last 6 years, and I work on strategic and commercial projects within the Earth observation sector. And I also write the TerraWatch Space newsletter focused on analyzing the Earth observation market. Looking forward to the webinar.
Thank you, Aravind. As usual, I have Carlos with me here today. This is not your first Orbify webinar, you already know that Carlos and I are like partners in crime when it comes to our webinars. Let's do a quick warm up and just to give everyone time to arrive. Our usual question is, where are you guys logging in from today? So I'm personally in France. Carlos, your tour?
Hi. Yeah, I'm in Brazil right now. So greetings from Brazil. So where you guys are in the world, please drop in the chat. New York City.
New York. Yay. We usually go like pretty global when it comes to our webinars. And it looks that way again. Yes, everywhere.
Yeah.
Oh, hi, Mario. Sorry, just saw him in the chat.
Yeah.
All right.
Prague, Barcelona, Sardinia, Taipei, Spain, London, Argentina, Ireland. Well, we are super global today.
Poland, Portugal. Well, Carlos is normally based in Portugal. Netherlands, Germany, Miami. Well, Miami, I'm sure you're having better weather than me because it's 10 degrees, well, 10 Celsius, so which is what, like 30 degrees Fahrenheit and raining, so not the greatest one. Hi, India, South Africa, Philippines.
Sorry, just because I saw Nestor. Hello, and Nestor from Argentina, one of our friends here. Morocco.
We've got Washington, D.C. Hi, Joel. I lived there for 7 years. All right, Senegal. Okay, Ukraine. Hi, Ukraine. Denver, Kenya, Zambia. Our founder traveled to Kenya about 4 months ago, I think.
Yep.
All right, it's 4:05. Let's cover some quick admin topics. So Aravind is going to do the full presentation. This time we only have one speaker. Usually we have a couple. So you can put in your questions in the chat as he goes. However, he'll address them in the Q&A after he's done with the presentation. We also have prepared a couple of polls. Actually, I think Carlos is going to release one right now because we simply want to know who you guys are in the audience. It will also give some understanding to Aravind because maybe then he could, I guess, adjust some of the ways that he would talk in the presentation. So please head to the poll and start typing in, start selecting the answer. It's very interesting for us as well. And then there will be a couple more polls during the presentation. You will see them popping up in the chat. Last but not least, the white paper itself is going to be released as a handout at the end of the presentation. So everybody who is attending live is going to get their copy at the end of the presentation. And for any of your colleagues or friends that are not able to attend, they're going to get their copy together with the recording of the webinar tomorrow. So, the answers are popping in. Very interesting. It's pretty much all over the spectrum. Very cool, guys. All right, we're 7 minutes in. Let's give this maybe like a couple more seconds for the poll to close. Aravind, you can see the results of the poll, correct? Okay, cool. And Carlos, is there anything else we should add?
No, so just during the presentation, keep an eye on the polls. And any questions, as Olia said, drop in the chat. We will mark your question as a question for the Q&A session, and Aravind will take over on these questions afterwards. So that's it. I hope you guys enjoy, and we can start, right?
Yep. Aravind, the floor is all yours.
All right. Thank you, Olia. No pressure. There's people from around the world, I guess, who've tuned in. I'm going to try and share my screen. Can you confirm you can see it?
Not yet. Yep, we can see it. And I'm gonna spotlight it so everybody can see it on full screen.
All right. Okay, sounds good. So you can see the screen. So let's get started. So the aim of the presentation today is to discuss or to give you like a preview of what you're going to find in the white paper in terms of the the satellite-based solutions that are available for climate and sustainability. This is presented as an independent review that's done by TerraWatch. Essentially, the goal is to identify the segments of the Earth observation market that are related to providing insights related to climate and sustainability, and then we're going to do a quick presentation on if you're an end user and you're a user of Earth observation data. How can you decide which is the best option for you? Because obviously, as you'd know, the market is pretty fragmented today. There's a lot of growth happening in the Earth observation market. A lot of satellites are being launched, and yeah, it's important to know that we are at the stage of the market where we are seeing a lot of evolution. We are seeing a lot of new entrants. We are seeing the introduction of new solutions like the one from Orbify. So it's important to identify where we are and try to get a sense of where we're going, but also identify what works best for you. That's kind of the goal of the presentation. I'm going to go quickly to present TerraWatch. So TerraWatch, for those who don't know, is a strategic advisory and market intelligence firm focused on Earth observation. And I usually try to focus on the 3 A's, which is availability, awareness, and adoption. So TerraWatch works across all of the threes. So by availability, working with Earth observation companies on strategy, go-to-market, positioning, marketing, and a number of efforts, as well as working with investors on due diligence so that the right kind of solutions are being developed in the market. Awareness, as you know, I try to do that with the newsletter and the social media. TerraWatch and myself is to spread awareness about the value of the Earth observation market. And with adoption, it's essentially strategic assignments done together with the end users. So an insurance company, a bank, an agriculture company, a forest company, everyone who is interested in using Earth observation data, helping them understand what's going on in the sector and helping them develop a strategy for how to use Earth observation. So that's a quick overview of TerraWatch. We can go into details. You can check out the website, and if you have questions, I can answer. But I want to jump right into the presentation, and we're going to go straight in to the details of the applications, right? So obviously there are several applications of Earth observation for climate. We are not going to go into every application into detail. I'm sure some of you who are joining in are probably working on one of these applications, and the application presented here are also kept on a high level. So we don't go very specific because, as you know, Earth observation is a very horizontal technology. And I always say the beauty of Earth observation and the complexity of Earth observation is its horizontal nature, because you can literally plug Earth observation into, many or most applications related to climate and sustainability you're talking about. And here we have three categories, right? So it's split as a function of how the market evolution would look like. So climate is everything that's related to climate intelligence. Environmental assessment is related to all things that are specific to sustainability reports and environmental assessments done by large enterprises. And then there is the emerging, let's say, market or segment called compliance coming in. As several of you are aware, there are a lot of regulations coming in globally, in Europe, in the US, and in specific countries around the world. In the UK, most countries around the world are having some sort of climate regulation, which makes use of Earth observation data in most cases. So those are the three kind of overall segments of the applications for Earth observation. Going into each of them just quickly. So greenhouse gas emission monitoring and reporting, as you'd know, this is very specific to the reporting of greenhouse gases, so carbon dioxide and methane, that have been the most warming gases, greenhouse gases that we're releasing into the atmosphere. Again, there are a lot of satellites being launched to monitor greenhouse gas emissions, and you can talk about this application itself for an hour, but obviously I'm guessing you all understand what that application means. If you have questions, again, drop it in the questions. The second one relates to carbon accounting. So this is a little different from the other, because if the first one is more related to emissions and greenhouse gas monitoring, the second one is more related to carbon projects, so carbon accounting, really. So if you're looking at carbon offsets, whether you're looking at blue carbon, forest carbon, or soil carbon, satellites have a role in monitoring it, measuring it, estimating it, and that's where carbon accounting use case comes in. So that's another use case. The third one is related to climate risks. So again, a lot of, risks as a result of climate change, particularly due to extreme weather events. And you can look at it in short term or long term. Short term, that is more weather forecasting, but then long term climate risks is more related to if an asset is susceptible to flood risk, wildfire risk, drought risk, or a city or on a national level, right? So that's climate risk. So that's the climate segment. Going into environmental assessment, we have air and water quality. This again is pretty straightforward. Satellites play a huge role in monitoring air pollution, measuring air pollution, and looking at water quality. Second one is related to forest monitoring. So forest monitoring is a particular one because there's a lot of deforestation activities going on, and it is part of sustainability reports of a lot of companies looking at deforestation efforts, but also looking at wildfire risk, for instance. So all of that fall into the forest monitoring category. And obviously you have the general land use in terms of how the evolution of land use really, is this being converted into cropland? Is a building converted? Is a natural environment converted into an urban environment? Artificial, structures, things like that. So seeing the evolution of that, that's more related to land use. That's the second category. Third category, compliance. Again, I didn't see if there were a lot of regulation-oriented people in the audience, but then obviously, if you have kept up with the news, you've probably noted that there are several regulations coming up. The first one is related to biodiversity impacts. So biodiversity impacts is simply everything that is affecting biodiversity as a function of human activities, whether it is to factories, whether it is to our own economic development. What is the impact of biodiversity? As you know, satellites can, identify, classify different sorts of biodiversity, but also help monitor it over time. So looking at impacts. So this can be, this can be the natural environment, but it can also be biodiversity in terms of the biosphere. The next one is deforestation regulation, which is probably closer to some of you who are in Europe, because you probably have seen the European Union deforestation regulation, EUDR, which requires a lot of companies, large companies, to report their deforestation levels, or how much of their products is susceptible to deforestation, from where they're coming. So deforestation monitoring is going to become, or is already a law in Europe, and companies have to start reporting very soon. That's deforestation regulation. And obviously, as you know, satellites have a big role to play. And I'm only going to keep repeating it. And we're not going to get into the technical side of it in this discussion. But it's important to understand how satellites have a role across each of these use cases. And the last one is related to sustainability reporting. This is what's, again, another European regulation that's coming up, Corporate Sustainability Reporting Directive, CSRD, that's coming up in Europe, I think likewise in the US, several parts of the world, where companies are, required to report a lot of the things that we saw before. They're supposed to report their climate risk. They're supposed to report their greenhouse gases. So I think a lot of applications that we discussed fall into the compliance category, because in a lot of cases, compliance almost acts as a business case for a lot of Earth observation applications, because Earth observation as a technology can do a lot, can measure a lot of things, but then the so what is often forgotten, right? Like, okay, so what? You can classify different type of trees, and we didn't really have an answer for so what before. But because of the compliance and some regulations actually require a level of specificity, like what is the type of deforestation, what is the kind of trees that are being deforested, right? And now we have finally found the so what in the market, because Earth observation has been going through a phase of searching for a problem, if you will, because it had a lot of capabilities, but it did not really have something to match. And I think the compliance segment that's happening right now, or it's emerging right now, is actually answering a lot of the so what questions. So that's just a quick overview of Earth observation for climate. I'm sure you probably are working on other types of applications. If you think that there are other applications that may have been missed or you want to see, please just add it to the comments, and we can probably discuss that after. And we're going to go on to the next one, which is to look at the commercial landscape. So we saw a lot about the applications and what Earth observation can do. Now we're going to look into what the commercial landscape looks like. Looks like there was a poll that was released, so I think a lot of people already answered it. But the commercial landscape is very much, you can segment the commercial landscape in so many different ways that if some of you have read the blog and the analysis that's been published by TerraWatch, you have seen probably an evolution of so many ways to categorize the Earth observation landscape. The simplest way, which is what a lot of people do, is to call it data and value-added services, right? So that is the most traditional way that is used. It's it's very simple. Data is data. Value-added service is something done on top of data. But I wanted to get a little more deeper, right? Because I think it's important that the Earth observation market evolves and kind of matures as well, because not all value-added services are the same. Not all companies that you may have heard of are the same, because some are data companies and some are value-added service companies. But then I think we have to get deeper, and that's what we've attempted to do here, is to segment it into three, and also to not make it too complex, right? So the three that you see on the screen here are, once again, data, starting from data, which is related to raw imagery, solutions that is more related to automated analytics, and applications, which is about advanced intelligence. So I don't know if that already gives you an idea of how we're trying to segment the market here, but I'll get into deeper over the next couple of slides. But just to give you an idea, data is simply raw imagery, right? So, if you can go into the complexity of identifying what is raw imagery really means. Is this analysis-ready data, or is it data that is right off the satellite, like L0 data? I think we can have a discussion about that, but then on a high level, I think the data layer is all about the raw imagery. And I think the best case scenario for the data layer looks like, instead of using raw imagery that is just being directly downloaded from a satellite, it's better if it's calibrated, validated, or rectified georeference. So, to have some form of analysis ready data, right? So that's the best case scenario for the data layer. For some users, for some applications, we'll find out that the data layer is probably the best way to go. The second one is solutions, right? So solutions is all about automating the analysis that's being done. So solutions can be tools that you can go to get or to do analysis in a way that is automated, as opposed to outsourcing something, right? So historically, what's been done in the Earth observation market was, you outsource it. So you develop custom projects. You basically do project by project. I want to measure deforestation over Indonesia. You outsource it, somebody does it, and that's kind of been done, and that still is happening. But then what I see the emergence of is solutions, which are essentially software as a service model tools, where you have a level of automation embedded into it. The analysis done is automated. The level of analytics it can give is also automated. And I think Arbify, again, the host of this webinar, is a good example of a solution in the solution segment, and we can discuss that more. And the last part is applications. The application part is usually very vertical specific, meaning the companies and the solutions that you will find in applications are actually probably not even called Earth observation companies, because they are so vertical specific and that can give you so much advanced level of insights that they are very specific for solving a specific problem. So let's take flood mapping as an example. So there are companies that you may have heard of that are actually working on that and that only. Their goal is to provide near real-time flood maps after a disaster event, and that is the company, right? So that is the focus of the company. Another example, climate risk. There are companies that are building proprietary climate models to project what is the level of wildfire risk, what's the level of drought risk in a specific area. So that's an example of an applications company, because of course they are automating it, but they are so deep and specific for a specific problem, right? So that's really the difference between solution and application. And I think it's probably going to get a little more clear as we go through the presentation. So yeah, if you have questions, feel free to drop. I want to go into the data layer. I don't want to kind of talk about it too much because, obviously we have the white paper and you can read that for more. But then to just look into the data layer, right? So what is, if you're, someone who's never used it or someone who is using it today, there are some aspects that you need to consider, when you're talking about the data layer. Obviously, if you're new to or if you're an expert in the industry, this may seem very obvious to you. But then the things to consider are essentially, if you are, looking at the data layer, obviously you need to look at what's the type of sensor. Some of you may know that there are a lot of sensors being launched, obviously from commercial companies, but also we have, institutional missions like Sentinel or Landsat. And there are sensors that are, optical, multispectral, thermal, hyperspectral, synthetic aperture radar, LiDAR, and there are a lot of sensors. And of course, you can talk about the sensors alone for 1 hour, looking at each of the applications. But that's an important thing to consider if you're looking at, buying imagery, because not all data is built the same. And there's a good chance, one type of data may not be the answer for what you're looking for, because maybe the area that you're looking for is full of clouds and you may need to have synthetic aperture radar to go with it. Or you may want a specific characteristic like, the land surface temperature for which the thermal infrared sensor is better. So if you're, an end user or someone who's looking to leverage Earth observation for your solving your problems, looking at the sensor is probably the first thing to start. Second is obviously the spatial resolution. So as the name says, it's about, how accurate and how much detail that you want to see in the image. Do you want to see the detail as specific as a building, or you want to just monitor an area of a forest? That can dictate the type of sensor, but also the pricing, right? So depending on your use case, it's important to look at the spatial resolution. Obviously, the temporal resolution, meaning how frequently do you want to have the imagery taken over the same point of time. You have satellites that are now able to collect sub-daily because there are so many satellites up there, satellite constellations, that they can image the area on a sub-daily basis, meaning more than once, twice, 3 times per day. If that's what you want, and that's your use case, that's one thing to consider. But then obviously, if you're looking at something like a reporting that's done on a monthly level, obviously that's good enough, right? So I think the type of resolution, spatial and temporal, will dictate which is the provider you want to consider, because in data providers, as I mentioned, there are several companies out there, and I didn't want to show the infographic that I usually have, where we have about close to 6 dozen, so 70 to 80 Earth observation constellations that are currently in space or being planned, commercially speaking. And then, apart from that, you have close to 1,000 satellites today in orbit that are Earth observation satellites. So, the choice of a provider is not really an easy one. And these are kind of 4 choices to consider. And the fourth one is obviously pricing. I don't need to talk about that. Pricing models are evolving. Once again, we can keep talking about pricing models as much as we want. But then the pricing models that are emerging, you don't have to buy an entire scene anymore. You can just buy an area of interest, and you have pricing models from different companies that offer that. So it's important to remember that pricing is it's a consideration when you're trying to go into the data layer. We talk about more in the white paper. So you can check that out. Going into the next one, so solutions. So I talked a little bit about what solutions represent, right? So solutions are all about providing automated analytics. So essentially a tool that allows you to process and get analytics from satellite data in an automated fashion. So with solutions, there are 4 things to consider again. So domain of interest, because not all solutions are built the same. And it's almost impossible to build a solution that can serve every different domain in the world, right? So if you want agriculture related insights, if you want forestry, if you want carbon, if you want emissions, you want flood, it's almost impossible to have one platform to do everything. And so the emergence of the market obviously has been that there are solutions that are now they're becoming specialized, so to say. So domain of interest can be carbon, domain of interest can be sustainability, or it can be sector specific, right? Like it can be a solution that is only meant for insurance. So if you want insurance related analytics related to satellite data, so geospatial analytics related to insurance, you have a company doing that. You have something related to sustainability, you have a company doing that. So it's important to identify what your domain of interest is, because then you may at least start focusing your efforts on the right solution. The next one is platform readiness. So platform readiness is an important concept because, remember I talked about before the ability to outsource. So a solution is not about that. It needs to be ready, meaning if you come with a problem, let's say you want to see the level of deforestation in a part of Brazil from 2008 to 2023. It's not, you don't need to outsource it and wait for 3-4 days to get the result, right? Like the solution should be ready. So the platform readiness actually just says how quickly are you ready to provide the final result. So you can even call it time to value. Is the time to value 10 minutes? Because if you have the right tools and the right data set, you can get the result in 10 minutes, right? Especially if it's already available or if it needs to run from the beginning. It's not going to take a lot of time given that a lot of the processing now is happening on the cloud, right? So platform readiness is an important concept and it's becoming more important as companies start to use observation because they don't want to wait. They don't want to think of this as outsourcing, right? So they don't want to wait 5 days before someone comes with a report. So platform readiness and the ability to generate results in a timely manner is important. And third thing is adaptability. So adaptability is more about, is the platform able to provide only a visual layer, right? So there are some solutions that are only map specific, right? So if you want, let's say go back to the deforestation example, you want to measure over 15 years, there are some solutions that can give you a map, but then maybe you don't want a map. You want that in the form of a spreadsheet. You want that in the form of an API. You want that in the form of a dashboard. Or maybe you're trying to report for the upcoming European regulation and you want it in a specific template, right? So the platform cannot just say, this is my output, go deal with it. There are some platforms which can actually give you a level of adaptability where you can customize how the results look like. And it's important in the world of climate and sustainability, as you know, because we have different countries, different regulations, and different use cases by different sectors. They all kind of look for the similar result because, think about deforestation as an example, right? Like you have a level of deforestation that you can see spatially via a map. But then if you want to report it or use it for some other further analysis, you may want to have that in a form that you would appreciate. And that's where I think being adaptable for a solution helps. And I think a lot of solutions are also going in that direction. And the last thing is price. Obviously, it goes without saying, for the data layer, I talked about pricing from a different context. For the solution layer, it's from another context because solutions need to be priced because, let's say you're one of the end users that you said yes in the poll, right? You want to figure out, okay, you know what, I'm going to measure, let's say, I don't know, flood in a specific area to figure out if this zone is, flood prone or not. You want to go to a solution and be able to know how much it's going to cost to know the answer. Because a lot of the times it's obscured. You may need to send an email or you may need to have a call to understand. But then platforms are leading to a space where we are able to provide pricing. And this is very similar to the software as a service model, where if you're going to go and subscribe to Zoom, you know that it's, I don't know, $19 or 19 euros per month. And you know that upfront. And solutions are actually going towards that because they are becoming more and more automated. And it's important for I think the industry to also move that way, because if you want Earth observation to be useful and adopted by a lot of people, we need to say upfront how much it's going to cost. And I think that's where having transparent pricing helps. And there are solutions that are heading in that direction, where you can go into the solution, understand what the solution can do, but also how much you're going to pay, so that you can do a better ROI analysis, right? So if a tool is asking for, I don't know, 5,000 euros per month or $10,000 a year, you can make a better estimate of, does this make sense for me or not, right? So I think pricing becoming an important context in the observation market for solutions. Again, more in the white paper. Last thing on applications. So applications, as I mentioned before, is very vertical specific. So it's specific to a sector. It's aimed at solving a very specific problem. So obviously you have to pick a solution which is aimed at solving a specific problem. And you can actually differentiate between a solution and an application very easily, because applications tend to be very, very, very specific. They can only do flood. They can only do forest carbon assessment. They can only do greenhouse gas monitoring, right? So they may not try and offer everything because they are going in depth, right? So if you look at, breadth strategy, breadth level strategy and depth level strategy, they are more, going in depth. That's the kind of companies they are. So you can differentiate which companies can help for your specific problem, especially if you want very in-depth insights. That's one way to find out, the application segment. The second one is methodology. It's important to figure out how applications work, because a lot of times you'll figure out that applications tend to be black box, right? So you ask for, what is the flood risk over this specific area, and they give you an answer: flood risk is 8 out of 10. You want to know how that 8 out of 10 happened. You want to know what data sources were used, what algorithm was used. Can you go and actually verify if it's peer reviewed or not? And the methodology becomes very important, because this is not magic, right? Somehow the analysis was done and prediction was done. And I think this has some analogies and parallels with what's happening in the artificial intelligence world and the conversations we are having there. But I don't think we are doing that level of prediction in our industry. We are trying to identify what the flood risk is based on historical data, and more often than not, the methodology can be mentioned, or at least talked about and discussed. So methodology is an important consideration. The third part is value add from EO. You may find several applications who say they use satellite data, and you really want to know what the value add from satellite data is, because it's important to know what the value satellite data brings before going and using an application, because you can differentiate: do I really need to pay $10,000 to go and use this application, or can I just use another tool? Maybe it does not use satellite data, maybe it just uses ground sensors, maybe it just uses drones. You need to figure, it's important to figure out why satellite data is important and what is the value it brings. And a lot of times it brings a lot of value, right? Like the obvious ones, it's scalable. You have demand in Indonesia, but you also have demand in Canada. And you cannot fly a drone everywhere, or you cannot install sensors everywhere unless you have got it already installed, and if it's cost efficient. But then in some cases, satellite data happens to be the scalable solutions. In another case, it may not be the right solution. So it's important you understand, if this application is using satellite data, why is it using? And the last part is scalability, and I touched on it before. If you're looking at an application, especially something that you're trying to subscribe, almost like SaaS, then you need to know if this solution is actually scalable. Because if they only have almost a pilot that works only in the south of France, then it's not really scalable, right? Then you may just go and choose another option for you. So it's important to look at from the application layer. So just a couple of considerations of all the three layers. And now we'll jump on to a question that I guess a lot of people are wondering, right? Like, how do you choose your Earth observation product? And what we've done is develop 5 kind of things to differentiate and think about while you're looking at using Earth observation data, whether it's in the form of a data solution or an application. So let's go by one. We have 5 of them. So the first one is requires in-house EO expertise, right? So there are solutions that require, or your need require, in-house EO expertise. if that is the case, then if you have an in-house EO expertise, then the data requires in-house EO expertise. Solutions, you can just go and buy them off the market, start using them for automated analytics. Same case with applications. It does not require in-house EO expertise. You don't need to have it. Right? Very simple. Second one is about costs. Again, there's a level of generalization here that I want to say up front because there are so many solutions in the market, so it's very, very hard to benchmark everything out there. But then in general, the data option happens to be the expensive one, not just because data is expensive. You can also just use free data, right? But then there's also an added cost of resources. You need to put together the team. You need to pay for cloud capacity for processing the data. So there's a level of cost that comes with using the data. But then we'll find out, there are some cases data is probably your best option. But obviously, if you look at solutions and applications, they are relatively less expensive because a lot of the processing is already taken care of by the company, and you don't have to deploy anything. You just have to deploy the solution, right? So from a cost perspective, depends on which option is best for you, but then the data happens to be an expensive option. Do you want an automated, ready-to-use analytics? Of course, a lot of them will say yes, but then in some cases you may not want automated. Like I said, you probably want to measure something for a very specific purpose. Listen, I'm just interested in getting something for reporting the next regulation that's coming up. Then maybe the data strategy may not be the right strategy for you because your goal is to only report. So solutions that answer your specific question can be the answer. So either solutions or applications can be your best bet. And I think it's important to also understand, as I mentioned when I presented the solution slide, every domain, every solution is focused on a specific domain. And if you are looking at the right solution for your specific domain, let's say within agriculture or let's say within the sustainability space, you will find that a lot of the solutions can provide automated analytics. So you have the ability to get automated analytics. And if that's your requirement, then you don't have to use a data layer at all. You don't have to deal with buying and managing all the data. The next thing is kind of related to that level of customizability. Obviously the application layer provides you, it's almost a software product, right? So you can't customize it too much. So the application layer happens to be something that just answers your question. So if your question is, I want to know the flood risk in this area, it can give you the answer, but there's a cost that goes with it. But then if you want to customize it for your own use, or you want to see how this can be integrated into your process, maybe having the data layer or going for a data product makes a lot of sense, right? So customizability, again, is another facet. And the last one is, does it provide in-depth intelligence? By that, I mean, in-depth intelligence is how deep do you want the insight to be? Do you want the flood map to be very near real time and very accurate because you're an insurance company and you want very, very specific answers? Then obviously you can go and look at the application layer because they are very meant for that purpose, right? The solution layer sometimes can answer your question, but then if you want deeper insights, like let's take forest carbon as an example. Forest carbon, can you find a solution that gives you forest carbon levels in a forest area? I think you can find a solution for that. But then if the accuracy part is very important and you want to look at the models and you want them to use different source of data because you want the very accurate forest carbon estimate, then it's better if you look at an application segment. So essentially, this is just kind of an attempt at a framework to figure out which use case makes sense for you. But obviously, the result, the final solution is not easy. There's no cheat sheet of if you have this use case, this is the right answer, because you can always find something else, right? So even with what I said, maybe some of you have problems with it because you're saying that, I can also do that with data. I can also find that in the market. And that's actually the beauty of the market today, because we have so many options, and I think that's the result shows a lot of you do not know which provider to choose. And I think that's one of the things that we're trying to demystify here. And I'm going to end with 2 points, right? So the first point is the choice of your product for your use case. It's not straightforward. So if you think that it's straightforward, then then you probably have to do a little more work in order to make it straightforward. And what is the work? And essentially three things. You need to do a level of trade-off analysis, meaning, like I said, you cannot have only one option. You always have like 3 or 4 options, right? So we need to figure out what is the best trade-off, which is the best option for you based on a trade-off analysis. And how do you find that out? You do a couple of feasibility studies, right? So you figure out like, okay, option A was go and buy data and use the data from this source and derive the insight, see how the result looks like, and then compare that with another option, another scenario, and do a couple of feasibility studies to figure out which one works best from a technical standpoint. And obviously, the third point is commercial. Maybe the second option gives you the most accurate result, but then it happens to be very expensive, right? So we kind of have to do 3 or 4 steps before the answer becomes straightforward. And even in that case, the answer may not be straightforward. And if that is the case, then you can go to the second part. So the second part, I talk about 3 things. The 3 things are reliability, scalability, and credibility. Usually, when we try Earth observation solutions, and I've seen that with a lot of end users, they're very excited in the first time to try something out, and it works out. And then they end up in a situation where we have done a couple of pilot projects, but we don't know where to go after. And that's when I bring the perspective of reliability, scalability, and credibility, because and sometimes they bring it up themselves because they have 2 options. But what's important for them is if they're designing a business case around this solution, they want the solution to be reliable. Meaning, if they do not know if the solution is going to work 6 months down the lane, they don't have to go with that option, because reliability is important for them, because they are changing their internal organizational processes for incorporating this technology. So if it's not reliable, or if they not see signs that it can be reliable, and reliability can be as simple as a function of, do you have a product that is going to continue to be developed over a period of time, or are you going to stop? Are you going to continue the deforestation monitoring product every month, every day, and you're going to keep it updated, or are you just going to stop it because that's not of use for you, right? So that's important for them to know. Second part is scalability. So something that we discussed before, different organizations have different needs. If you have a very scalable need, you need to know, or you need to see proof that the solution that you're seeing is actually scalable. You're trying to report emissions over your pipelines, and if the emission works over North America, but it's not going to work over Australia, you need to know that it's a risk that you're taking, because maybe they don't have the algorithms and the models for Australia. They have not done the vegetation management portion for Australia, right? So if they show signs of scalability, then you can go for whatever option shows signs of scalability. And the last part is credibility. So credibility is, again, an important part, and it's something that I addressed before. How do you make sure the result that they're providing is actually credible? And integrity is, again, becoming a more important part, especially as we have compliance use cases coming up. You need to know if the result that this company is providing is actually credible for you, right? So if they say this is the level of deforestation that happened in your area of interest, you need to know how that happened, right? Like, you need to dig deep into how that insight was derived. Maybe you don't need to understand everything about remote sensing, right? So for those of you who are not remote sensing people, you don't need to understand the whole aspect of remote sensing, but you need to understand how the data became an insight. And I usually have an infographic to go with it, right? So data that is there, usually what we see in our industry is there's data and then there's insight, right? Like, we often forget what's happening under the hood. That's something that we don't see, is what is the level of calibration validation that's happening, right? Is the data calibrated, validated, or it's actually not good data, right? It's an important component. For public missions, you don't have to worry about it. But then for commercial missions, it's something that it's not a question that you need to ask. It's almost a trust that you have with the provider. Same with the fusion, right? Like, is only one data source used? What is the data source that is being used? Apart from ones that they have advertised, so that you have a level of transparency over how the process happened. And then for the processing part, what level of algorithms, or what is the type of algorithm that was implemented to get to the result? Because as more and more companies start using Earth observation solutions for climate insights, sustainability insights, this demystification becomes more and more important, because they need to know what's going on under the hood. again, you don't need to become remote sensing experts, but I think it's important that you also keep that in mind while you hunt for the next Earth observation solution that can solve your problem. I guess, yeah, that's basically it for the webinar. You can find a bit more analysis and insights on the white paper, but I've tried to cover as much as possible here. Hopefully that was useful.
All right, I think you can.
Sharing.
Great. And we're back on. Thank you, Aravind. Hopefully, guys, this was pretty insightful for you. Now comes the best part, the questions. So we've got the first question from Catherine, who is saying, we're a carbon project developer. Can you name a few companies that we should be considering for two specific needs, feasibility studies and ongoing monitoring?
Well, I think in terms of naming companies, there are several out there, and I'm just having a feeling that I'll forget some. So obviously, you can look at Orbify because they have potentially they can tick both the boxes. There are very specific companies in the application layer, which probably might be interesting if you want very in-depth intelligence. It depends on where you're based. There are a couple of companies in France, Canop, Wild Sands. There's a couple that's coming up. There's a couple in the US. Looking at Chama that can provide. They are a carbon credit marketplace. I'm looking at Satligence in Netherlands. There are a couple of them actually. So off the top of my head, I can think of 3 or 4, but I'm sure I've missed many.
Wow.
You take a look I'd probably recommend you take a look at my blog. I can try and see if I can find the link because you can find a lot more companies in that. It's not exhaustive. It's impossible to. The beauty of the market is it's impossible to be exhaustive because you can find applications or solutions everywhere from every part of the world. So it's important to be mindful that not all the names that I'm saying are exhaustive. Yeah,
sure. And shameless plug, as people would say. Obviously, as Aravind said, we're one of the companies that does it, and we're soon going to be launching a tool that we're calling a rapid assessment. So something that carbon project developers would be able to use to quickly assess if a project is worth doing the whole feasibility study. And in terms of the continuous monitoring, we've got a bunch of tools. So if you'd like to check us out, you can go to orbify.com and you can create a free account, or you can also get in touch with us. Excuse me. The next question would be, I'm specifically curious about EO data for methane emissions monitoring. I understand that GeoML techniques have gotten better at teasing out methane emissions from point sourced based on spectral signatures and or visual imagery, but that they still need improvement before being useful for less special resolved methane resources like landfills, waste sites, farms, permafrost, etc. Is my understanding correct?
Yeah, I think the first thing I'll say is it depends on what's the level of threshold you have, because there are commercial companies that are coming up like GHGSat, which can go up to a threshold of 250, if I'm not mistaken. So it depends on the level of threshold you have. I mean, do we have data? Of course we have, because we have data that's coming in at least from 2 institutional satellites. So there's EMIT that I can think of. There's a sensor that's installed in the International Space Station. There's obviously Sentinel-5P and commercial companies like GHGSat that are coming in with their proprietary data. So I think it's a function of has it gone better? Of course, GHGSat's data has been validated and it's being used in a couple of areas. Obviously, you have another company in France called Keros. They also have a methane monitoring tracker. They just released an open version of it yesterday because today COP is starting. I think as in a timely manner, they released this methane tracker from them. So you can check them out. Obviously, they have different data sources, so the results might vary. They have their different methodologies. So I'm going to go back to the presentation. So look at what methodologies they use. It's not just about the data. Obviously, data plays a part. But yeah, it's important to remember which data source kind of matches your expectations, because if you're, different companies have different tolerance limits, to put it simply. Sometimes you may not need a level of accuracy that you think you need. I think it's also a human thing to overestimate how accurate we want. Sometimes we think we want too much, and that happens to be very expensive, or maybe it's not available. But then in reality, you do a feasibility study and you find out that, the spatial resolution that you need may not be what's necessary for what your application requires. That's what I've seen. That's just based on what I've seen working with users.
Thank you. There is a question connected with the question there, so I'm skipping a few, but I'm going to go back to them. So the question that is connected is, how close is the market technically to crack carbon estimation using remote sensing to finally bring transparency to the voluntary carbon market?
That's a good question. I actually just published a deep dive on Earth observation for carbon markets today. So I did a lot of research on this and spoke to a lot of people. How close we are, I think it's, again, depends on how accurate we want to be. Do we want to be 100% accurate? I don't think it's even possible, because, it's remote sensing, as the name says. So we can't expect, 100% accuracy. But I think we are closer than what we were 5 years ago. And I think a lot of the voluntary carbon market challenges and problems come with the ability to not use technologies like satellite data. But now we are seeing a lot of uptake. If you look at, Verra, which is one of the ratings agencies that's setting the standards for carbon credits, they are starting to adopt a lot of satellite-based solutions and remote sensing-based solutions. So we are definitely getting closer. We also have companies like Planet that have released their forest carbon product, which is, a product that you can go and, buy off the shelf and try that out. Obviously, they have their proprietary methodology, and they will also integrate, I'm guessing, their proprietary data in the future. So I think we are closer than where we were even 2 years ago, I'd say.
How accurate do you think that could be when it comes to the carbon capacity estimation?
Is that the same question, or?
That's just a question from me.
Well, no, in terms of number, no, I think it depends on the tolerance limit, right? So I've spoken to a couple of folks who did not really mind even a large difference compared to, a ground truth, because they are looking to optimize for scale, because their projects are located in a lot of places of the world, and even if they can optimize to some level, they're happy. So if we show from start, the accuracy is not close to 90, but it's even like a 60, it's all right, because they're looking to scale. But then if you're looking at another type of a carbon developer or a ratings agency, they are looking to optimize for accuracy. For them, for some, it's hard to convince, right? So if they're going to stick to their methodology of, going in person and doing, verification and validation using ground truthing, and that's what they're going to stick to, or are they going to stick to drones because they like the resolution that, the LiDAR data from drones provide, they're going to stick to it. And I don't think we should focus too much on that, because there are always going to be customers who are interested in what we have to offer, and also early adopters, because some of them may not adopt unless we show more than 80% accuracy, and there's no use iterating with them, because they're going to come in after as kind of a late adopter. And I think there's going to be an early adopter market that's always going to be there.
Thank you. Next question. In the insurance sector, how has the EO data been used for risk estimation? Is there more applications other than plant mapping?
Yeah, for sure. I mean, from the insurance point of view, you can look at it in different ways. But then if you look at it for segments of insurance, so you have property and casualty, you have agriculture and credit insurance for farmers and such. And obviously you have the disaster and parametric insurance. So if you look into these three categories, there have been applications. So in property insurance, there have been use cases of satellite imagery, but used on demand, because property, as you would imagine, requires the identification of a specific building, meaning you want a very highly accurate or high resolution data, which is still quite expensive. So maybe it's better to use stratospheric balloons or aerial imagery, right? So the use cases of Earth observation for insurance are there, property insurance being one, identifying what the roof is made of, whether there are swimming pools or not in the house, things like that. There are obviously uses of satellite data. The next thing I mentioned was agriculture related, so credit risk insurance, credit risk, and then insurance for farmers. That's more related to identifying, crop yields and looking at, the evolution of over the season on a seasonal basis, monitoring the crops. So again, there's another use case there, depending on where you are. I think the demand will be different, because if you're in a developing country, the farms are very small, so you need very high resolution data. But if you're, let's say, in the Western world, your farms are very huge, so there are more. There's more adoption because data is available for free. For example, using Sentinel-2, which you can use, and that's good enough for your use case. So it depends on whether there has been validation or not, but the use cases are there. The third thing is obviously parametric insurance. So parametric related to floods is one thing, wildfires is another thing, right? So anything related to any sort of disasters, extreme weather events, parametric insurance, obviously one of the emerging use cases within the insurance sector. Hopefully that makes sense.
Are there applications that are selling metrics instead of the full platform? As such, they can be more scalable. The client has to insert the metrics into their existing platforms.
Yeah, 100%. And that's exactly what I would say the solutions segment in the landscape, that's what's focusing on. And if I'm not mistaken, so by metrics, you can do metrics in different forms. Metrics can be in the form of an API, right? So you can just use an API and get your result. Metrics you can just look at and download from a dashboard. But also you can have metrics that are sent to you in a spreadsheet or in a report form. And there are companies that are starting to do that. And if I'm not mistaken, Orbify can also do that. Correct me if I'm wrong. I think there are solutions that are coming in that can obviously do that. And as you're saying, yeah, it'll be great if we have a lot more solutions that can output results in a form that is usable by the end user rather than a map. I use an example of a map during a presentation, and I think the geospatial industry has been, in love with maps a little too much, and more than what the output or the end user might care, right? Like the end user might want to look at the result on a map, but then for the next steps in their analysis, they may want it in the form of an API, or they may want it in the form of a spreadsheet, right? So I think that's where the industry is also going, or in the form of even a template. So I think that's where the industry is going. So you can definitely find a lot of solutions like that in the market.
Thank you. Before we jump to the next question, Carlos, would you please release the white paper in the handouts? Because there were a few questions about that. So guys, watch out in the handouts section. You're going to get the copy. Obviously, you also get it in the email tomorrow. Next question would be regarding biodiversity. I'd like to know more about the biodiversity monitoring using satellite data. What indicators are possible now? What about the precision and uncertainty? You're on mute, Aravind.
Sorry, my bad. Yeah, I think it's a good question related to at least the uncertainty aspect. I've seen a lot of research on it, and I know at least there are a couple of companies that have started offering biodiversity metrics in terms of classification and identification of different variables. The question is, can the solution answer to what your needs are? And I think the answer is to be determined on a case-by-case basis, because I've seen cases where the biodiversity impacts needed to be, I guess, reported as part of their sustainability reports. And there were a couple of feasibility studies done, and the satellite-based data did not really have enough bands, or at least at that point, to get to a level of certainty that the client wanted. So I've seen cases on that extreme where satellite data was not a good indicator. And the second part is you may find solutions in the market today, but then how willing are they to report and be transparent about their uncertainty? That's the question, because can you identify this variable? Can you classify this type of tree or flora or fauna? You can, but then what level of uncertainty do you need? And then on the other side, is the application ready to be, or the company ready to be transparent about it in terms of the uncertainty involved in their methodology? I think that's kind of been, and I think there is also a part of data gap, because have we had data with as many bands as different variables as one of the EBVs or many EBVs, essential biodiversity variables will require? The answer is no, because we don't have many, for example, hyperspectral sensors up there. We are only starting to launch from a satellite point of view. Of course, if you want to use drones, you can use, but then from a satellite point of view, we don't have many satellites with many bands that are there. At the right price, and as an open data, it's not there. So you got to have to spend for it. And I think I guess I'll probably end with a consulting answer, which is, it depends. And if you have the right budget, I think you can get it. It's possible to get to that level. But then if you're looking for something that is, value for money, I think we still have some data gaps to fill. And that is going to be filled, right? Like for a Copernicus point of view, there's the hyperspectral mission that's going to launch. There are commercial companies that are launching hyperspectral sensors. So I think the EBV's gap is going to be reduced over a period of time as well. And I'm guessing also, Orbify, you have biodiversity as one of the analytics you offer, correct? I don't know what.
Yes, we do.
Offer. Yeah.
Mm-hmm. It's part of the, I guess, use case for the actual carbon credit developers.
Okay.
All right, guys, we're a couple of minutes over. We're going to take last question and then we'll close it out. So last question is, what is your solution to the black box problem for the private sector, where IP secures competitive advantage?
Right. Well, if only I had the answer for that, right? So I think the solution for that, I think it's starting to come about. One solution is probably in the form of peer-reviewed content, peer-reviewed publication, where the methodology and the data sources, training data sets, all of that are released publicly. And I know of at least one company that does that. So flood-based, that is more in the flood mapping and parametric insurance space. They do it. I'm sure several other companies do that as well. So I think peer-reviewed publication is one thing, one solution. The second solution that I can think of is looking at figuring out if it's the right use case and the right application. Can that become a public good? If it becomes a public good, or some sort of hybrid public-private good, where we have, let's say, a free version where everything is transparent, methodology is transparent, but probably the resolution. And I can think of like flood, again, as hydrological models as one example, because if you want to get a 20-kilometer hydrological model, you can go and get that for free. And you can look at the methodology. It's released by NOAA, it's released by ECMWF. But if you want 1 kilometer, you have to pay a company, right? So for me, that seems like one of the solutions where we may have a public version for a lot of the variables that we're talking about, where all of the aspects are public, including the code, and the private part where, if you have a higher resolution need or a higher temporal need, right? Like if you want it every day, then you need to pay, and that is going to be behind an IP. But it's at least leveraging what was released in the public IP form. So that's kind of the status quo in the meteorological and weather climate world, and I think we can probably take some best practices there.
Thank you, Aravind. Since we're a few minutes over, we would like to close out this session. We'd like to thank Aravind for the presentation and for the answers to the questions. We'll take, I think there are a couple of questions that were left unanswered. We'll follow up with you guys over the email. As we said at the very beginning, you'll get the copy of the white paper as well as the recording of this webinar to your email inboxes tomorrow. And please feel free to stay in touch. You've got all the links in the chat, so you can connect either with ourselves or with Aravind. And we hope to see you in our next webinar, which is going to be dedicated to EUDR, one of the regulations that Aravind has mentioned at the beginning of this webinar, that is going to happen in January. We're going to be releasing the sign-up page very soon. And thanks again for coming. We hope that you enjoyed the presentation, and have a good rest of your day.
Thank you
so much. Bye, guys.
Bye-bye, everyone.